Well, I've got a little bit sidetracked with another project while painting my Stuart half beam, and in this video I'm going to install a rotary table controller for my small rotary table. So this particular project is based on the Ward controller, and you can get details of these two components from the World of Ward website. I'll put a link in my description to that. So this is the Ward controller and this is the keypad, which is quite nice touch to that. You can buy these made up, or you can buy the individual components and make it up. I bought it all complete. You need a box to put them in. I 3D printed that. I designed it myself. It only took 19 hours on the printer. I also designed this cover myself. I mean, they do provide a template, but I thought the keypad was a bit too close to the display, so I've separated that a little bit. They also provide sort of a sample of a cover you can print, and again I've slightly modified that to make the distance a bit more between the keypad and the display. You obviously need a stepper motor, so this is a 2.2 nm stepper motor from cncforyou.co.uk. You need a stepper motor driver. This is a DM542T stepper online one. You need a linkage to link the motor to the rotary table. Now I downloaded the STL files from Thingiverse. Again, I'll put a link in my description to this, and I 3D printed these. And if these don't work out, okay, I'll probably just make them in metal, but that seems sort of quite sturdy, to be honest. And you need a couple of power supplies, so that's a 9 volt and this is a 24 volt. And you also need, or I need, a lot of help and advice and guidance, and I've got regarding the electronic side, and I've got that from Adam. Adam is sort of a genius at electronics, and he's really good at providing good advice. I'll put a link to his YouTube channel in my description as well, and I'll also reproduce some of the diagrams he's supplied me to help me with this project. Okay, and I'd like to thank Adam for sending me these bits and bobs in the post. So there's some quite substantial 4-core cable there. There's some thinner 3-core cable with a grommet type connector on. There's some of this stuff, I think it's a heat shrink stuff, I'm not too sure. There's a fuse and one of these 4-way, I think they might call them XLR connectors, I could be wrong. And this is something I 3D printed from Thingiverse, and it's a grommet to hold this cable inside the housing. That looks quite neat actually, so hopefully that'll work out okay. Well, actually these spacers I made, they're 9.5 millimeters long, and they just seem to be right, because all of the keys work really nice, so I'm happy with that. So what I need to do now is think about how I assemble it in the box. Now I think I'm going to put the stepper driver sort of in there. I think I'm going to put this cable here through the top, so that'll need this a hole drilling for this grommet, and I need to think about me input power. So I've got a couple of these connectors. I need to sort of just give it a bit of thought in terms of where I'm going to put these connectors. So once I've got a plan, I'll drill the holes and I'll get back to you. Okay, so for the box, what I decided to do is to open up these areas with a drill bit to enable me to epoxy resin these nuts in place. These are 3mm threaded nuts, and that will enable me to secure the top nice and firmly. So what I also did was I drilled a hole in the top here to take this 4-core cable, and I used epoxy resin to hold the grommet in place. They are 3D printed, so that's nice and secure. What I also did was, with these walls being quite thin, they're only 2mm in thickness, I 3D printed another piece of plastic and used some epoxy resin to stick that in place, just to give that a bit more support. So that's looking pretty good. Now I also need to drill a hole through for the 2 power cables. So one's at I think 9 volt and the other one's 24 volt. And I'll use the same principle really, and use some epoxy resin and a grommet to hold it in place. But I'll do that a bit off camera. Now, in terms of the process moving forward, Adam provided me with sort of a bit of a checklist really, of a sequence of events to follow. So I'm going to use that rather than show diagrams of circuits, because I mean, they just get confusing to me, and I don't know about other people, but I think following a checklist is going to make it a lot easier. So on Adam's checklist, first of all, order of operation, set the dip switches on the driver. So the dip switches need to be set like that. So we've got the first one on, the second one off, third one on, fourth and fifth off, and the rest on. And there's a thing there that tells you what those settings mean, but I won't go into all of that. So that will fit down here at some point in the future. Now, the next thing is, what did he say? Now, for the motor, he supplied me with this little box here. So he told me to drill a little hole through here for the wires to come through, and also drill a hole in the side to enable this 4-core cable to come through here. And I've epoxy resin that onto the motor after using a bit of sandpaper underneath just to rough it up a bit. Now he suggested that the motor wires be cut down to 75mm, which is what I've done, and connect the orange and brown together, solder and heatsink. So he gave me some little some heatsink material. Now I've used a hairdryer on that, which isn't overly effective, but it seems to sort of work. And also connect the blue and yellow together, solder and heatsink, which I've done there as well. So actually, having done that, if I look at the instructions for this stepper motor, that tells me that it's going to be wired as a bipolar series. There are 2 other options available. You can do bipolar, parallel and unipolar, but from what Adam's saying is we're going for series. Now what I need to do off camera now is to connect these 4 remaining cables to this 4-core cable. Obviously the colours won't match, but I need to keep a note of, you know, which colours go to what. Once I've done that, I'll then tidy up all the cables in here and put the top on. So I'll do all that off camera, and then I'll get back to you with the next sequence of events. Okay, so when I connected the 4-core cable to the stepper motor, I connected red to red, black to black, white to white, and green to yellow. So that yellow is effectively green. Now, I then connected the stepper motor wires to to the stepper driver, and the red goes to A+, the black goes to A-, the white goes to B+, and the green, i.e. yellow, goes to B-. Now in terms of the 3-core cable, this comes off this strip here and connects into the stepper driver here. So let's have a look. So DIR, which is blue, connects through to there, which is DIR plus, and then the step stroke pulse, which is the red, connects through to the pulse plus, and then the ground, which is the green, connects through to the DIR minus, and then it loops round to PUL minus as well. So on the power supplies, I cut off the DC barrels and checked polarity, and on the 9 volt I connected through to the World of Ward controller, and on the 24 volt supply I put an inline fuse on the positive line and connected that to the plus V and the negative to ground. So hopefully this should work. Well, I've used some double-sided sticky tape to stick this on, and I've powered it up and it says enter profile, so I'm not too sure what that means. I've not read the manual yet. Anyway, I press C and it's come up with the modes. So if I go for division mode, maybe 2, it says number of divisions, so I'll go for the default 60. Press go, do we? Well, the right hand button's not doing anything. It's going up in increments, but the motor's not running. Go backwards. So reverse is working, but forward isn't. So I'm not too sure what's going on there, so I'll have to take it apart and check my wiring. Okay, so I checked all my wiring out and it seemed to be okay. So I ended up having to contact my 24-hour support line, aka Adam. So he spent about an hour with me exchanging emails and trying to do various diagnostics, and anyway eventually suggested changing the wiring setup between the World of Ward controller and the stepper driver. So what I've done based on his suggestions is connected the green to 5 volts and connected the green onto the stepper driver to DIR plus, and then looped it round to PUL plus. Check that's right, yeah. And then I've taken the DIR connection, which is the blue connection, and connected that to DIR minus on the driver. And then I've taken the step connection, which is the red, and connected step through to PUL minus. And having done that, it all seems to work okay. So I'll put the top back on and give it another try. Okay, so we'll give it another try. If I go into continuous and press left, that was good. And press forward. Hey, that looks good. Happy with that. I also went into setup, and in setup you can set the number of steps per resolution of the rotary table. Now my rotary table is in 90:1, and the number of steps per revolution here I've set to 400, so 400 multiplied by 90 is 36,000, which is what I've set it here. So hopefully when it gets connected to the rotary table it'll function correctly. Well, for the connection between the motor and the table, I 3D printed this sort of connection, and the housing is pretty good, quite robust. But I've just found out that the bits that go in the middle to do the connection aren't good at all. This has just ended up spinning on the motor shaft. So I think what I'm going to have to do is to make something like these on the mill and the lathe out of something like aluminium or mild steel bar. So once I've done that, I'll get back to you. Okay, so I've just remade that using some mild steel bar. I've used a couple of grub screws to hold it onto the shaft, which is far better than just a push fit like that. These I might remake this one that fits onto the shaft of the rotary table. We'll have to see how that goes. I don't think it's a significant problem at the moment. But anyway, I'll put it all together and we'll see how it runs. So this is the acid test. So what I've done is I've gone into the division menu and I've said I want to divide it into 4. And it's a speed of 5. I think I can change that. Yeah. So if I go speed of 1 first of all, and then do this forward arrow, so that's clockwise. Ooh. You can't increase the speed when it's moving. Increase the speed up to 5. Try again. And counterclockwise. Well, that was an interesting little project, and I can't thank Adam enough for all his help and support. I couldn't have done it without him. The only thing I really sort of messed up on, which wasn't anything major, is this connector that Adam sent me. And apparently it's a chassis connector, so that should have sort of gone on the side of the box to enable the lead to the motor to be unplugged. But in the end I hardwired it in, and then I realised what that was for. But you know, it seems to work okay. Adam also suggested that the connector or the linkage between the motor and the rotary table is an Oldham style type of connector, and these little discs that I 3D printed, apparently you can buy them in metal form. They're called acetal discs, ACETAL discs. So I might look out for those, some of those in the future, but it seems to work okay. And I'm not checked for backlash, but fingers crossed it'll be alright. So anyway, I hope you enjoyed the video. I hope to see you later, and I better get on finishing painting my Stuart half beam.